Hi, thanks for attending my talk virtually. It's great that we were able to convene this conference virtually with all the craziness going on. So I'm going to talk today about some work that's been going on in North America with cross-laminated timber, some fire testing that's been done, and how this has led to adoption in the US building codes. So cross-laminated timber is a type of mass timber. If you're not familiar with it, it's dimension lumber glued together in alternating layers, and it makes these giant panels that can be delivered and erected very quickly. So on the far left side of this image, we have a mass timber ceiling. This is actually in what was the tallest mass timber building in the United States, the Carbon 12 building, and you can see you have this CLT ceiling, and it's supported by glue laminated columns. And one question people have about CLT as it's starting to become adopted and used in North America is we want to understand performance in fire scenarios. And so one of the first big tests that was done in North America was funded by the Fire Protection Research Foundation. And it was carried out by the National Research Council of Canada. Joseph Sue is the lead author on that, and they were performed at the National Institutes of Standards and Technology. And in this test, there were two different compartments. They were identical, except that one had a large opening factor and one had a small opening factor. And the goal of these tests was to understand the contribution of CLT to the compartment fire. And you can see the data, or some of the data here. So on the left, we have test 1-1, and in that test, everything was encapsulated in gypsum wallboard. Test 1-5, that was the same compartment with a small opening factor, but here one of the walls was not encapsulated with gypsum. And you can see at the beginning of the test, they're pretty similar. It decays a little bit more slowly when there's the exposed CLT, but towards the end of the test, we have what's called a delamination, which led to fire regrowth. And that's when the CLT loses a layer of adhesive, or the adhesive fails before the char reaches the adhesive bond line, and that drops fresh fuel into the fire, and that caused fire regrowth. But the opening factor has a huge effect on this. So you can see the blue curve there. That's the same one wall exposed, but with a bigger opening factor. And while you do get fire regrowth a little bit during these delaminations, it extinguishes itself more quickly. Were performed at the Alcohol, Tobacco, and Firearms Laboratory by the Forest Products Laboratory, and these were in support of the International Code Council's ad hoc committee on tall wood buildings. We ran 5 different tests, and these had a much bigger opening factor. The compartments themselves were much bigger. In these, there was no fire regrowth observed in any situation. And we looked at 5 different scenarios: a fully encapsulated case, a partially exposed ceiling, partially exposed wall, and then 2 fully exposed compartments where the effective automatic sprinkler systems were examined. Finally, I wanted to talk a little bit about this PRG 320 product standard. So to qualify yourself as a CLT adhesive in the United States, you need to pass a full-scale test where it's very similar to the FPRF test, where it has a similar opening factor, and you need to be exposed to a similar temperature profile as the FPRF test and not have any temperature increase at the end of the test. And so in this little figure here, there's 3 different adhesives that were tested. And you can see that the pink adhesive there fails. It has fire regrowth, and that was the same adhesive used in the FPRF test. Since the FPRF test, there's been some improved adhesive formulations, and now the PRG 320 compliant adhesives do not delaminate under this fire scenario and are much safer. So that's all the time I have. But please feel free to reach out and communicate me further if you have other questions. Thank you.